Hi, thanks for joining us. This is the Gear 8 end of year assessment to review video for my students. But if you're joining from the outside world, this is basically the second video of two videos that pretty much summarize everything that I would expect Year 8 to be able to know and be able to do by the end of Key Stage 3. So without further ado, what we're going to do is we're just going to review the questions. There are roughly around about 10 multiple choice questions, and then there are around about 20 marks worth of open response questions. So the first question was, Momin had four substances. Sugar solution does not change the color of green universal indicator. So it's, of course, it's a neutral solution. Second question, my students always, they know that and can always expect some question about apparatus. I love to throw an apparatus question at them. This was Noor investigating how copper oxide reacts with dilute sulfuric acid. She needs to measure out 50 centimeters cubed of acid. It's this piece of apparatus that is vital for that, and that is a measuring cylinder. So the correct response was D. The next question, a lot of people do get beaker wrong, I found at the start of this year. So this was always going to be a question that I just wanted to make sure that people understood which one was a beaker. Of course, it's B. To heat the water, you need F, which is a Bunsen burner. Next question, Wasan doing an experiment. The indicator solution turns green when she adds an acid with an alkali and then tests it with indicator. This is a neutralization reaction. Jana adds sulfuric acid to pieces of limestone. Limestone is calcium carbonate, so the reaction is calcium carbonate plus sulfuric acid reacts to form water plus carbon dioxide plus calcium sulfate. And the carbon dioxide will trigger off a positive test for carbon dioxide in the lime water. The lime water will change from colorless to a milky white, cloudy color. So you have a white precipitate of calcium carbonate reforming. It's interesting because the calcium theme runs through to the next question as well. Calcium hydroxide reacting with sulfuric acid, so you get a salt and water, but the salt is calcium sulfate. Sulfuric acid always gives sulfate salts. If you look at the number of letters in the formula of ammonium nitrate for the next question, you get N, H, and O, and those are three elements. So the first response is the correct one. Adnan adds nitric acid to some sticks of chalk and sees bubbles, so obviously a gas is produced. The interesting thing is that the nitric acid is reacting with calcium carbonate and you're forming carbon dioxide. So what's actually happening is that the acid is reacting with the chalk. This is actually quite a straightforward question, but and it was good to see that hardly anyone was caught out on this one. The only time where people were caught out was the fact that people just went in and thought that maybe there's just one answer, even though the number 2 is highlighted in bold twice in the question. Just goes to show that you must make sure that once you finish the paper, you go through it and you read it very, very carefully. You could be dropping a mark inadvertently, especially if you ever had to choose between the two and both are right. The next question, actually, I spent a long time doing some research. I actually really like this question. It says, the first family rave in Dubai in 2017, and they had a lot of glow sticks at the event. They were giving them out to children. And which of the following would decrease the rate of the reaction? So immediately, rate of reactions, things that affect the rate of reaction are temperature increase. So these would increase rate of reaction, temperature increase, surface area. So if you increase the surface area, if you increase concentrations, if you were to use a catalyst as well. But in this particular one, the question was asking which of the following would decrease the rate of reaction. So the last response was the correct response. Decrease the temperature of the glow stick before breaking them would decrease the rate of the chemical reaction. Catalysts do not get used up in the chemical reaction, so the third response is the false one. The other three are true. The pH of citric acid, it's a weak acid, so you would expect a number of roughly 4, 5, or 6, either of those numbers, or even a range if that was given, was enough to get the mark. Indigestion tablets neutralize acid in the stomach. What does this tell you about indigestion tablets? It means that it is an alkali. Now, they do need to be soluble in order to act fast, so but a soluble base would have been an acceptable answer. And even if a candidate just wrote they react with the acid, that would be a sufficient one. You could also give an answer in terms of pHs, so long as the pH was above 7. But if you were to say, oh, well, that must mean that the pH is 8.5 or 9, that wouldn't be sufficient. You just need to indicate that it was on the alkali side. Now, I really did want to give the mark if the student actually said, yeah, this is the reason why this well, basically what this tells us about indigestion tablets is that it's a base. Soluble base was the only one that I could actually get a response to, and it does. The reason why is because in the first part of the question, he dissolved 1 gram of each substance in 20 centimeters cubed of distilled water. Now, if you just said a base, there are 2 different types of bases. One is an insoluble base, like a metal oxide or certain carbonates as well. And you can also get soluble bases as well, which are alkalis. So if a person did write or did type base, I couldn't give them the mark for that, as much as I'd wanted to, unless they indicated that it was a soluble base. The next question, I really liked to design questions to reflect the time, and this was on a bottle of bleach used to clean surfaces and combat the spread of COVID-19. This is, of course, an irritant. The sign of a chemical reaction that you need to look out for is that if you see it in the liquid when the gas is being formed, you see bubbles. Protective equipment, goggles, that's what you're looking out for if you need to avoid getting drops of bleach into the eyes. Next question, a lot of text. What color is copper sulfate solution? It's blue. This is related to a whole lesson where we actually made the crystals in class. The copper oxide is a black solid that's actually left over. You can pick that up from the passage. The word equation, copper oxide plus sulfuric acid reacts to form copper sulfate plus water. Nena had to filter the mixture because all of the acid had reacted, so there was some leftover copper oxide which needed to be separated out. If it wasn't separated out, you would not be able to end up with pure copper sulfate crystals. Any sensible suggestion? Gloves, or they could use a dustpan and brush or a broom to pick up the mixture, or even they could actually use a pair of tweezers or tongs to pick up the large parts of glass. Hibber's suggestion works because some of the parts of the mixture that you have are too large to fall through the holes of the sieve. The mixture, Minsay put the mixture into water and stirred it. The water turned blue because the blue copper sulfate dissolved, and that was the key thing. You couldn't just say the blue color went into the solution. You actually had to have a distinction between it just mixing with the water and dissolving. It actually dissolves the particles, the oppositely charged ions of copper sulfate. The copper splits up from the sulfate and it dissolves in the actual liquid water. So you had to say that solution forms or it dissolves. The volume of the solution decreased when Minsay gently heated the liquid because the water was evaporating. It was turning into a gas. For that one, you had to be very, very clear and very, very careful with your description. After having done that experiment, he leaves it by the window. Next day, no liquid left. What would be left in the dish? Copper sulfate crystals would be left. You had to specify crystals. What could form a neutral solution? Well, you could have ammonium chloride and sodium sulfite. Those two, when mixed together, could form a neutral solution. If you added sodium nitrate to another solution, if you added it to ammonium chloride, some people thought that if you just add lots and lots of sodium nitrate, eventually the pH of the solution would actually neutralize, it would eke out. But no, you had to have one on one side of pH 7 and the other on the other side of pH 7. if whatever you have that's behaving like an acid, if you put magnesium is so reactive that it will form hydrogen and magnesium salt. So the observation that they would expect to see, Salma and Grace would expect to see, are bubbles, and the gas that they would expect to be formed is hydrogen. And final question: the formula for a different carbonate compound is K2CO3. That is actually potassium carbonate. There's three elements that make up that compound are potassium, carbon, and oxygen. And that takes us to the end of our second assessment review. Thank you very much for joining us. I would expect Year 8 to be able to get their heads around these levels of questions and this standard of questions. And thank you very much for watching, and stay safe at home. Bye for now.